Alright, as the last video ended, we had just explained how the distance, the general distance, from the top of the upper hemisphere here down to the lower would be this radical r squared minus x squared minus, and then this bottom one was represented by the negative. Put those together plus, and that's how we get the 2r squared minus x squared, square root of that. Now, we want to set up an expression that calculates the average value of that function. Now, the average value, remember, is 1 over b minus a, an integral from a to b, and then there's our function, and we can simplify that 1 over 2r right here, and then we bring our 2 out. Then the question becomes, how do I get this 1/2 pi r squared? Well, if you look at this part right here, the derivative of r squared, or I'm sorry, the square root of r squared minus x squared, and you're looking for the area, again, what we're looking for here is we're looking for the area underneath this semicircle. So the upper hemisphere only. And so how do you find the area of a circle? Pi r squared, but since it's just a half of the circle, we go by 1/2. So the 2 and the 1/2 there can cancel, and r can cancel, and I'm left with pi r over 2. Alright, the last thing we want to talk about in this lesson is the relationship between the derivative and the integral. Now, the derivative and the integral, much like division and multiplication, much like addition and subtraction, are things that offset each other. They're inverses. So if you were to take the derivative of an integral function, you just end up back at the original function. So you see here that the derivative and the integral would cancel each other out, and you end up back at the beginning. Now this has all sorts of implications for us. For instance, we can find an integral using antiderivatives. And we've got this formula right here. The integral from a to x of f of t dt is capital F. Remember, capital F represents the antiderivative. So the antiderivative with x plugged in minus the antiderivative with a plugged in. And we're going to use that to calculate this part right here. So first of all, we ask ourselves, what is the antiderivative of sine? Well, we know that the derivative of cosine is negative sine, but there's that negative that throws in a problem. So the antiderivative of sine is negative cosine. So I'll take my negative cosine, and just like they plugged in the two parts here, see there they plugged in x, here they plugged in a, I'm going to plug in pi, and I'm going to plug in 0. Go to the unit circle. Cosine of pi is -1. Cosine of 0 is +1. So -1 plus +1, and we have a total integral area of 2. And there's your homework. Not too long. It's actually not too complicated. I hope you are having problems with it. If you do, again, feel free to work tomorrow and ask all kinds of questions in class.